Hello, good afternoon. So we will now learn to use the timer on your switching for delayed starting, star delta starting. Okay, so I will use first the timer to switch the motor to forward or reverse direction. It doesn't matter if it is in forward or reverse, so as long as we are planning it to reverse the direction or change the direction using the timer. So I have made a models of the contactor and the timer, the thermal overload relay, so that it is easy for you to connect or experiment in start Y delta starting. Okay, so we have a 5 volt power supply for control circuit, and while on the controlled circuit, we will be using 220-volt three-phase. Okay, so you will start with the push button switch. I have here push button, and I will use a momentary SPDT for a stop button. Okay, and then I will just connect this, and our power supply is 5 volts. Okay, just for the control circuit, and I will just connect it, and we will just edit it later on. Okay, so the first one here, I will be using the contactor C1. This is your main contactor. Okay, this is your main contactor. And then I will put the push button normally open. I will put it on A1. And then A2, I will put it on the ground. Okay, so we have a 5 volts power supply. And then we have a holding contact of 1, 3, and 1, 4. Okay, directly connected in parallel to our push button. Okay, so after our contactor, we will be using the thermal overload relay. So I will put here thermal overload, and then I will put the three-phase supply. So I will check about three-phase supply here. So we have here three-phase supply. I will just rotate, and then we will configure it. So we will put here RMS, and our phase voltage is 127, so that we could uh, determine a 220 volts line to line, and then put it on 60 hertz. Okay. Okay. And then the three-phase supply, we will put here this one. I will put this here as line one. And then second, the line 2 on our 135 terminals of the conductor. And then after that, 246 will be connected to our thermal overload relay. Okay. And then the 95, 96 of the thermal overload relay, I will put it here. Okay. And put it here before our stop button. So I have here 96 below. Okay. And we will go to our uh, supply. Okay. So put it there. And then after that, we will be putting the motor now. So we have the three-phase motor. Okay, I will make it far so that there is a space to connect our forward and reverse contactor. So I will put the first direction here using this C2 contactor 2, and I will put the lines here. I will make it a little more farther so that we could have space for the connection. And then we have here two, we put here in one, and then four. Okay. Okay. And six. Okay, and then we'll put our motor here. Directly connected to our motor. Okay, and then we will be putting our reverse contactor, and then I will put one here without uh, reversing the connection. Then the third one will be below. Okay, then first connection will be at the bottom since we are planning it to reverse the connection. Okay, third one will on the uh, okay, so our forward and reverse contactors are already connected, so we'll complete our control circuit. So for our control circuit, we will put the timer here, and the timer is directly connected. The supply of the timer, pins 7 and 2. So 7 will be connected to the A1, and 2 also be connected to the ground. Okay, so 2, that is for your ground for the Andy model, the timer, and then the common, which is the pin 8, would also be connected to our power supply or for the A1 of the main conductor. Okay, so for the normally closed, I will use the upper conductor to control first the direction of the motor, and then this normally closed before putting it to the A1 of the say forward contactor. I will put it first to the 2-1 normally closed of our second contactor in order for an interlock for our protection. Okay, so I will put now this connection to our A1. Okay, and then the second connection normally open. Second contactor will be activated, but I will put this first also to the interlock 2122 of the first contactor, and finally going to our A1. Okay, so let us go to our A1 there, and both A2 of the contactors should be connected to the ground. So A2, and then I will put this on ground. Okay, okay. I think all done now for the timer, connection of the timer, and then for the thermal overload relay, I will just put here to control the temperature. We'll see that later on. So I will just use an electronic uh, temperature sensor. And then here for terminal 1, I will put EPP1, terminal 2, and terminal 3 to terminal 4. Okay, so our temperature is 27. We'll just adjust it manually in order to simulate if the thermal overload will be triggered if it will reach a certain temperature, such as 75 degrees or more. Okay, so we will put an ammeter. Okay, we'll put an ammeter so that we will see if the motor is indeed reversing or being stopped because of the inertia set for the motor. We cannot uh, determine if the motor is still running because or it is being stopped because the motor shaft is still rotating. Okay, so we'll just put here on a meter so that to indicate that the motor is indeed um, stopped. Okay, so I can delete this one. Just move this. Okay, make it bigger by examining. Okay, so that's it. So we have our meter, and we'll put also a voltmeter. Okay, could also put a voltmeter plus the motor or the power supply so that to check whether we have indeed 220 volts on our lines. Like that. Okay, so we'll start. Okay, let's see if indeed the timer can switch the directions of the motor from forward or reverse. Okay, so simulation on. I will turn this push button on. Okay, so motor is starting. Oh, it's on already on the reverse direction, so we'll be expecting that the motor will have a positive rotation after the timer will be done. Okay, so I think it's already switched to a reverse direction because it is approaching zero, and then now it's on positive direction. Okay, so we have now the timer is working, switching from a different direction, okay, to the opposite direction. So we have a 1800 RPM and our full load current is 19.2 amperes. And we have a 219 volts line to line. Okay, so you will use this timer and contactor models so that you could test it on Y delta starting. Okay, so we can also change the temperature here manually so that we could see if it's indeed working, if it reach a high temperature. Let us see here what is our setting here. Okay, 53 still on. So current is still flow to the motor. Then a 65. Okay, so we will increase it further. 67, 69, still okay. 71, okay. 73, okay. 75, okay. Okay, so it's 76. Okay. 76 degrees. Current is disconnected or the line is disconnected. The motor is still rotating because of the inertia setup for the motor. So the thermal overload works, though we are just simulating it to change the temperature. And then I just want to demonstrate it using the timer in this forward reverse application. But for you, you have to apply this connection for our star delta, and you have to measure the starting current or the run current at Y and the run current at delta.